Welcome to the first lecture for a flipped model we're using this year. This is Chapter 2, Section 3 on chemical properties. All right, so what you should have in front of you right now is your guided notes packet and a pen or pencil. So I'm going to be writing other things on the slides in addition to the notes that you're going to need to write in. So make sure everything I say goes down on your piece of paper. So let's jump right into it. And I hope you enjoy my really fancy title page that I hand drew. All right, so I want you to look at this slide here, this slide of this car, and think, what's causing this rust? Okay, well, the answer is there in the caption, and you can see it says you've got iron, which is this car is made out of, reacting with the oxygen. So this oxidation is what's causing this rust. Here's an example of a chemical change. If you can see the second area here, which I'll draw on. Whoa. Says the bumper on this car still looks new because it's plated with chromium. So chromium has a different chemical property causing it to have no reaction with oxygen. So you see the difference, right? You see the iron here, chromium here. Let me change this to a different color. Boom. Chromium here causes that to look brand new while this car has been sitting in the sun for who knows how many number of years exposed to the air. All right, so this chemical reaction, this oxidation you can see right here is an example of what we're talking about today in Section 3. Contrasting to Section 2 where we talked about physical changes, we're actually going to see the substances themselves change. So our objectives today are to describe two examples of chemical properties. So we're going to be looking at two specific ones, and actually I'm going to give you some more at the end as well, so you could actually say more than that. We're going to have several. We're going to explain what happens during a chemical change, and we're going to really distinguish the difference between physical and chemical changes. I'm going to put a star next to that because that's probably going to be the most important thing you should take away from this lecture. So, first of all, you can compare physical and chemical properties without changing the identity of the substance. So observations don't mean you're changing, right? So I can observe something with a chemical property by using some testing. I can test reactivity. I can look under a microscope and look at the atomic structure of these chemicals. But chemical observations and observations of chemical properties are a lot more difficult to observe than physical properties, right? So yesterday I had you think about an orange and describe that to somebody. That's really easy to do in comparison to thinking about the chemical structure of, let's say, an orange. It's a lot more of an involved process. Characteristic properties, which I want you to define right here in your notes, are properties that are the most useful in identifying a substance that are characteristic properties. So these properties are what make a substance a substance. So when we're trying to distinguish two chemicals from each other, we're going to look at these properties. So what happens during a chemical change? During a chemical change, the substance changes chemical properties. It actually changes into something new. So if you think back to our slide of the car, that metal, that iron, that steel was actually changing into a totally new substance. So we call it rust, call it oxidized steel, whatever you want. It's a new substance. So when we know, there's actually usually easy signs that something's changing into a new substance. You can see the color would change, the odor might change. You could see a production of heat or fizzing. I actually would rather you call it nucleation or oxygen. Just kind of when we say fizzing, we're talking about bubbles. I know, sounds silly, but that's a good way to think about it. So if bubbles are produced, that means it's either carbon dioxide or another gas that's been made present, right, based on that chemical reaction. So let's think back to our Mentos experiment. That substance was produced when the Mentos reacted with the diet soda. Matter and chemical changes. So chemical changes change the identity of the matter involved. A new substance is created. So if you directly contrast that with physical change, there's nothing new created, right? When we took that can or the chalk I smashed with the hammer, we have the same substance, chalk, that's just been changed in its shape or its form or its structure. Nothing new is created. Whereas in a chemical change, we've got a completely new substance. All right, so here's some examples of chemical changes. We've all seen the space shuttles, which no longer fly. When you have the burning here of hydrogen and oxygen, you're creating heat. Obviously, that's an example of chemical change, right? And it's used to thrust the, I just like drawing arrows, thrust the space shuttle up. Oh, look at this girl. Gross milk, right? So it smells bad because bacteria has formed a new substance in the milk. So remember, we can ID a chemical change with odor. Boom, right there. We've got bubbles here forming from effervescent tablets. So Alka-Seltzer, some of the other bubbling tablets, right? So I'm gonna write down bubbles here. So it's a production of carbon dioxide, right? So we have a new substance being produced based on that reaction. Another one similar to our truck earlier, right? We've got Statue of Liberty used to be like a beautiful, like a amber copper color, but now it's green, right? Well, why is it green? As you can see right here, new copper compounds are formed, right? And a chemical change over time. So since that was installed, I'd say, I don't know, 200 years ago or so, it's changed color, right? So these are some examples of chemical changes. So this is a really important slide, and I definitely think we need to get all the notes down and think about this one. These two ideas, like physical versus a chemical change, a physical change does not result in a composition of a substance. So composition meaning the creation of a new substance, whereas chemical changes do. All right, so here's the definition again. The composition of a substance, I should say. The composition of a substance is a type of matter that makes up the object and the way that matter is arranged. Let's just delete that. Let's delete this too. Boom. So another key difference here is you cannot reverse chemical changes. So many physical changes are easily reversed. Let's think back to our soda can. If I wanted to, I could heat that up, melt it down, and make a new soda can, right? I could get some machines and flatten it out and make it normal again. My piece of paper, I could tape it back together, glue it back together, whatever. Make it pulp, recycle it, right? Chemical changes can't be reversed. Key difference here. Might be the easiest way to remember it here is that if I am, let's say, burning a piece of wood into ash, can I take that ash and make a new piece of wood? No, I can't. It's a totally different substance, and I'm unable to do that. All right, so key difference. All right, so here are 6 little pictures here. Let's try and identify which one is a physical change and which one's a chemical change. I'll start over here with the frying eggs. Excuse me. So, all right, I got my frying eggs. I've cracked them. I put them in the frying pan. I'm applying heat. We think back to our example for chemical changes. Something that usually gets warmer, right, is an example of a chemical change. We've actually got a new substance, so this is a chemical change. And also think about this, too. Can I reverse a fried egg, put it back into a normal egg? Ms. Beyer says no. She's right. Similar, toast. Okay. You might think, yeah, toast, that's a physical change, right? All you're doing is putting a toaster on. But again, can you change toast back into regular bread, Ms. Beyer?
No, not happening.
That's a chemical change. What about cracking eggs? Technically, you could put an egg back together. I'm not applying any heat, right? I don't create a new substance. I'm sort of just changing where the egg yolk is in the egg. So that's actually a physical change. Slicing bread. Easy one, right? Chemical change. Oh, just kidding. Nope, that's a physical change. All I'm doing is changing the shape or the structure of the bread. How about lighting a match? You might think, hey, it's just physical, right? I'm just rubbing something against something else. No, you're actually changing the sulfur, which is on the end of a match, into a new substance, right? You're burning it. You're creating a totally new substance. That's a chemical change. Finally, roasting marshmallows. Think to yourself, can you reverse that change, right? That's a key thing there. Can you take a roasted marshmallow and unroast it? No. I think one of the key things we're kind of seeing here is energy or heat being applied to chemical changes. It doesn't always have to be there, but it's a key sort of indicator that you're undergoing a chemical change, right? So we've got heat here, heat applied here, and heat applied here. So it's kind of one of those commonality, those little clues you can look for. Okay, so hopefully you've taken notes on all this and paid attention and not just hit mute and written down the blanks, filled in the blanks. You're going to have a quiz at the very first moment in class when we meet again, depending on your day. This will either be on an iPad in Schoology or a printed out form, depending on availability. So review your notes before class and be ready for the quiz. Thanks.